recitation with the tutorial. Did you go to the, come on, nobody? Do you know of your recitations? They started this week? Okay, well, then the answer is nobody then. Oh, okay. Oh, well, you will enjoy it, I'm sure. So let me just go to your blackboard. By the way, if you have evening classes today, it's canceled after 4:45. I will try to cut this one as a little bit short so you can go home. Yes. Today? Well, it's not going to happen. You can go to the other one. There are two. Well, then I don't know. Maybe for this week because it's canceled, you can set up some other time. You know. But we want to try to make you use Blackboard quite a bit. Blackboard is your mode of communication. So I emailed you, you email me, you email him. You see the news there, you see your homeworks there. I get these questions all the time, but this is the time that really get used to using the Blackboard so that there is nothing really hidden. If I get a question that is applicable to everyone, I'll post it on the Blackboard. If it's not, I just personally respond to you. I don't think there's anybody here who has emailed me and I haven't responded to them within an hour. So this is the sort of communications that we're going to have. The first thing we got to pay attention, of course, is your syllabus, right? So if you go to your Blackboard, obviously these are the recitation. You will find your names there, the time and the room. If you want the syllabus, you go on the left column. What is this? Why is this? Why don't you take a page and circle it around so we can get a kind of attendance sheet? Yeah, come on. So anyway, so on the Blackboard, all of you have access to this. So when we go to the syllabus, you press the syllabus, and there is a copy of it. Okay, so let me just make it a little bit bigger so you can all see. Now in here, you know, I tell you what the course objectives are, what the learning objectives are, but these are the explanations of our policy. On the homework, for example, you are assigned a homework on a weekly basis. It is worth 10% of your final course grade. All weekly homeworks are due by the 12 p.m. on the Monday of the subsequent week, which means today. So you need to submit it to your TA. Now, people have asked me, yes, you have a question?
Like, I have recitation like tomorrow. Isn't it due tomorrow for you then?
So, this is how I'm explaining it over here. But do you want to hand it to your TA? In that case, we can change that.
That's what he said.
Okay, so then to give it to the TA. But after that, then you can submit it. So if you're planning not to attend, then you need to do this. Okay? Lab policy, of course, is very well explained here, and the exam policy, you know, it's a closed book, but I allow you to bring some cheat sheets with you, about a couple of pages, 3 crib sheets, 8.5 or 11, but then you have to hand it in. Attendance, you know, by attending the class, you're going to get a credit. So all of these are added, as you can see, to 100% of the grade. Any questions so far? All right, so the next thing we want to do is, right, let's open up the so no questions about last time, the last lecture about lines, linear? Okay. So today we're going to talk about trigonometry, and if I can find it here. There you are. All right. What is trig in engineering? How many of you have had experience with this? One. All of you must have had it in the high school. Come on. You must have seen it. So what I'm going to, the whole objective of this class is to connect the math to engineering. So you may ask yourself the question, why on earth should I learn this? What has it got to do with, civil engineering, with mechanical engineering, electrical engineering? So what we want to show you here is, it is important. That's why we emphasize the fact that math is important, and you really need not to be afraid of it. It might sound scary, but the easiest thing is math, really. The moment you kind of clean your mind and then try to look at it very objectively, you will find out that math is really not that difficult. The person who makes it difficult is really you. So how do we use trig in engineering? The easiest thing that I can think of is called a link planar robot. Okay, so let's see, this is a robot, 2 legs, a body, and a link. You may find that this is a funny drawing. I mean, what kind of a robot is this? But many robots actually work that way. Just a simple hand. Okay? Anything mechanical. So we're looking at this, and we see a rigid bar moving by a motor in a counterclockwise type of operation. So we want to see what kind of a impact trigonometry has in such a robot. So when you're looking at mechanical systems like this, what is important for you? Everything in this object is stationary except one. What is that? What is moving in this? Yes. The link, yeah, the arm of a robot. So if that is the only thing that is moving, and you're interested in its behavior, you want to know where it is at any instant of time. So really, if I think about this as a rigid bar, what you're interested in, where is the tip? Where is the tip of that link as it is moving, right? So we want to know the position. So the position of the robot. So think about this as this is a robot in a manufacturing industry. It wants to pick something and put it somewhere else. Okay? Just like that. So you need to know where the position is. That's where trig comes into play. So in this case, what we want to know is that if we know the length and the angle, which is theta, where is the tip? So what are the coordinates of the tip of this link? Now I show this at P bracket X and Y. What does it say? Have you seen this kind of notations before? What does it say? First of all, it says P is a function of X and Y. Okay? What it also says is that the position of P, when we say it is a function of X and Y, that means the location of P is known if you know where X and Y is. So in other words, it's giving you the X and Y coordinates. So you want to know the end tip of this link. Where is it located? So how would I know where that is located? Any idea? Yes?
Would it be length cosine theta, comma,
Right, so that's, you are applying trigonometry, right? That's what you're using, and that's the whole idea of showing this, that first of all, what that is. The other thing, of course, is as this thing is rotating, is creating a shape, and your shape is a circle, right? Because every point, as this thing is moving and this thing is rigid, it is basically going in that direction. There is a terminology in math for that shape other than radius. When you know that the shape that it creates. Have you heard of the term locus? No? Well, okay, that's another mathematical terminology, but don't worry about it. Anyway, so looking at that robot, so the idea is that as this thing is rotating around the pivot, about where the motor is, it would create a shape of a circle. So what we want to know is what is basically x and y. The tip of that shape, what is x and y. Now, there are two angles that I am showing you, and this is something that you have to remember. In engineering, you know, it's kind of a selection. We could have selected differently. But in engineering, when we say positive angle, that means it is going in a counterclockwise direction. And when it's a negative angle, it goes in a clockwise direction. Now, somebody might ask the question, what is a digital watch? Then, you know, you don't have any clockwise, you know, it goes like this. But in any case, this is the values of theta in the clockwise. And so when I say it's a positive theta, you measure it this way. When you are saying negative theta, you're measuring that way. So far, so good? All right. So how do we measure these theta angles? So with the positive theta, it goes from here all the way to here. So how do we measure that? How do we measure angles? Yes, degrees. So theta is between what and what? From here is what degree? 0 and 180. So 0 to 180 degrees, right? 0 to 180 degrees. What does this mean? Okay, which means that theta is greater or equal to 0 and smaller or equal to 180 degrees. Do we measure angle with any other type of measurement? Radians, right. Radians. How many of you have heard radians before? Good. So instead of saying 0 to 180, we can say 0 to pi. If somebody you have a question? Your hands is up.
Oh, no.
Oh,
It was still
oh, just, I thought you were drawing your nail. Sorry. Okay, so positive theta, 0 to 180, 0 to pi radian. So if I want to measure it in negative, then what the negative would be? Come on, somebody brave enough. All right, so is that correct? Yes. Greater than minus 180. Yeah, because we are measuring it in the negative direction. Right? Negative direction. So when it gets to over here is minus 180 and 0. Right? So in the radian, how do we say it? 0 to negative pi. How many people agree with them? How many people disagree with them? How many people want to go home? There you are, you're right. So between 0 and minus pi radian. Now people ask questions, why is it 180? Where did 180 come from? Where did 181 come from? God knows. You know what? Somebody woke up one day and said, I'm going to call this 180 degrees. You know, in reality, if you wanted to make it very simple, you would have just made it from 0 to 200. So it's 400, because it really doesn't matter. What is telling us, I don't know what it is. What it's telling us is that we are dividing this angle to 360 times, 360, and each of them we're going to call it 1 degree. And it's all because I wanted to call this 90 instead of 100. It could have been that way, but that's where it came from. These measurements are really man-made. It wasn't really anything astronomical, right? So that's how we measure angles. In this case, of course, pi radian is equal to 180 degrees. So when I'm looking at, before we do that, let's look at an arc like this. Now, if I have an arc noted at S, this arc, which is part of a circle, an angle theta and a radius r, how do I measure this arc? Do you know? From geometry, yes?
R times theta.
Exactly. So S really is r times theta. So S is measured in what? No, it's an arc. It's a length. How do you measure length? Meters, inches, feet, right? How do you measure radius? Meters, inches, feet, right? It's a unit of measurement. The radius is a unit of measurement. An arc is a unit of measurement. Therefore, the length of an arc is basically S equal to r theta. So if I want to calculate theta, which is in radian, is S over r. So if I'm measuring it in meters, okay, and I'm dividing it by meters, what is the dimension of theta? Which we call it radian. Do you understand? I think you look lost. Okay. We measure arc S as equal to radius times theta, right? That part we understand. Then I want to find out what theta is from this relationship. I divide S by R, right? So what is the unit for S? Meters. What is the unit for R? So if I divide meter by meter, what do I have? Exactly. So radian is dimensionless. Okay? There is no dimension. It's not like you say radian is 10 meters. No. It's actually a dimensionless unit which allows you to really measure circumferences or radiuses. How do we know that? By knowing that S is, if the S is now circumference of the whole circle, right? If S is the circumference of the whole circle, what is the circumference of a whole circle? Circumference. How do you measure? 2 times pi r, right? 2 pi r, right?
Yeah.
Right. Always say pi d, which is diameter, right? 2 pi r or pi d, which is pi d diameter, right? So circumference, if I put it there, then theta is 2 pi r over r. Right? So I have the length of the arc as the circumference. I have the radius. I divide it. So theta is 2 pi. Right? When a whole circle is made, what is theta in degrees? 360 degrees, right. 360 degrees. So in other words, theta, which is 360 degrees, is equal to 2 pi. So from there, we find out that pi is equal to 180. Excuse me, let me just get this. Maybe it emerges for the university. Hello? Hello? Yes, I'm in the class. What is it? No. Okay, bye. All right, I think that the conditions are getting worse, but anyway, you don't mind. You can walk home. All right, so as we discussed, there is no dimensions for the radian. That's where the relationship comes from, where 2 pi is 360 degrees, therefore pi is 180 degrees. As I said, if we had put this one as 400, then pi would have been 200. Any questions? Yes. What is it? What is the answer to dimensional radian? Why is it dimensionless? What cancels out? Exactly. See? We're telling you that these units exist to assist you in your analysis, but they don't have any dimension. Dimensions are very important, and units. So when the time comes and I give you tests and quizzes and homeworks, you have to make sure that you use the right units. In engineering, units are very important. Now, what unit systems do we work with in this country? SI? No. I wish they did. We don't. You don't have SI in pounds and feet and inches. What is it? Yeah, those are metric. SI is a standard international, but that's international standards. But the units that we use here are American or basically British standards, English units, right? It's very confusing. If you go back 20, 30 years ago, people in this country would not have understood what meters are. But if you just go across the border either way, everything is now in meters. So you need to really understand both of them to some extent, because many of the units these days we only use metric systems anyway. But you have to understand both of them because many of the machineries or the equipments that we use are still using the old system. How many liters in a gallon? Liters. See, you better know that, because if you travel in Europe, you're going to be paying through your nose. 3.6 something, right? That would be the gallons here. But if you go to Britain, a gallon there is over 4.5. So there you are. So it's a very, but you might as well get used to liters because the rest of the world use liters. Anyway, so if you're traveling in Canada, for example, what's your speed in the car? Is that mile per hour? Kilometers, right. So you think that you're going 70 miles per hour, and then people are zooming past you, but it's only 70 kilometers, which is about maybe 45 miles. Anyway, so we know this part. So sometimes so X and Y, if you think about the robot arm, you think about a triangle, right? So in this triangle, I know L, I know theta, but what I want to find out is what is X and Y. What do we know L as? Yeah, Say it loudly.
Hypotenuse.
Hypotenuse, right? You've heard of the hypotenuse theory?
Yeah.
Right. So if I want to find out x and y, how do I find it?
It's like x squared plus y squared is equal to like L squared.
Right?
Oh yeah.
There you are. So L is simply square root of x squared plus y squared. That's the hypotenuse theory. But we also know this. Do we know this? That's cos of theta, or cosine of theta, the angle, is x over L. Have you seen this?
Yeah.
Right. So if you want to find a cosine of an angle in a right angle triangle, you divide the side that is closest to the angle by the hypotenuse. So if I want to find the cosine of theta, I divide x over L. Or in this case, if I want to find out what x is, if I know theta and if I know L, x is equal to L times cosine of theta. Right? So now, what we were saying before, that if I know the length of the robot, if I know the angle that the robot is making, I will be able to find the position of the tip of that robot by these two variables. Is that the only term that we know from that triangle? What is the sine of theta?
What oh, the sine of theta?
Yes.
Y over L.
There you are. Y over L. So sine of theta is y over L, which means that I can find out the value of y coordinates or y position of the tip based on the length of the arm and the angle that it makes. So let's go back and see, what were you trying to find? You were trying to find the position of the tip of that arm at any moment in time, provided you know the length and the angle that it makes. Right? Did we find it? Does it matter if theta is in radian or theta is in degrees? In this case, it doesn't. Really doesn't. Okay? Because, doesn't matter how your calculator works. Your calculator can be worked either in degrees or in radians. But what is important is, if I now put the value of x and y in the hypotenuse theory, which is up there, I have x squared plus y squared. Now, x squared is found over here, which is L cos of theta squared. Now, why don't I put theta in a bracket? I don't say cos of bracket theta. Again, this is some simplifications that we make. What we do in math, yes?
Because you would be taking the cos of actually 1 and then multiplying it by theta instead of taking the cos of theta and putting it in bracket.
Well, where's 1 is coming from?
The one is, it's implied because of the, I guess, the in between two functions when you separate them.
Over here?
Yeah, you said if you bracket theta, right?
Yeah, so he said, what I'm saying is, you might have seen, I guess, in your schools that you would say cos of theta. But I don't do that anymore. I just simply say cos of theta. It's implied that when I do it this way, this theta is an angle. There is no function cos theta, something else. So it is implied, and it's only for simplification. Because you're assuming that theta is an angle, and you're actually calculating the cos of theta. Yes? Yeah.
Isn't that equal to 1?
Well, you're jumping ahead. So you got to go to the class next door. No, I'm kidding. Class, they're not that smart. All right. So L cos of theta squared. So what is this one? This is L squared cos theta squared plus L squared sine theta squared, right? So what can I do? I can factorize L squared, right? Which is equal to L squared, meaning that cos square theta plus sine. These are the first rule of cosines and sines. Square of cosine and sine of an angle will equal to 1. And if you look at it and compare it to the top, then you'll see what the values of cosine square and theta square. The whole objective of this is that you compare this to what we have up here. And what we have up here, it says L squared is equal to x squared plus y squared. Okay? So if I compare the two sides together, that's what we have. Let me just go back. Any questions so far? Yes.
What does sin and cos stand for?
What does SIN stand for? Sine. Which is called sinusoid. Cosinusoid or sinusoid? Sine of, it's our the terminology in angles. A sine of an angle in a right angle triangle is the ratio of the side opposite to it over the hypotenuse. And the cosine is the one adjacent to it. These are the basic laws of trig, which of course we're not covering here. We're only talking about application. All right, so what other trig functions do we have? What is this? Tangent, right. Tangent or tan of theta is a ratio of sine over cosine. Sine of theta over cosine of theta. What on earth, how did I get y over x? Yes. So we have sine of theta divided by cosine of theta, right? So what is sine of theta from that triangle? Theta, this was L, this was Y, this was X, right? So from here, what is sine of theta? Y over L divided by X over L. So these two L's will disappear. That's why you have Y over X. Right? That's why we have Y over X. What other trigonometry functions do we know? Cotangent. Somebody said cotangent, right? What about this? Have you seen this? Yes, what is it called? Secant, right. Cosecant, yeah. Secant of theta and cosecant of theta. Somebody wanted to mess around with us, right? All these, why on earth do we need to get all of this, right? Secant simply is an inverse of cosine of theta. One would think, okay, if you're inversing it, why don't you call it cosecant? Because it's cosine on the other side, right? I have no idea why, but it goes back many centuries. Now, when I'm looking at this, and I say, okay, secant of theta is 1 over cosine of theta, and cosecant of theta is 1 over sine of theta, right? What kind of relationship would I be able to make from here?
Cotangent, no. Never mind.
So let's look at this. From the first one, can I find out what is the relationship between cosine of theta and secant? Can I say cosine of theta, therefore, is 1 over secant of theta, right? Can I say that? Yes. Right. But I want to show you what the relationship between these two are. So from the first one, I can find cosine of theta, which is 1 over secant of theta. And from the second one, I can find sine of theta equals to 1 over cosecant of theta. Right? So let's square them. And then add them. Well, I have cosine squared plus sine squared. What do I have here? 1, right? So what I have here is 1 over cosecant squared plus 1 over secant squared is equal to 1. Another relationship. You know, you got to come over there, you know, you're going to sit in the corner, then you can't see anything. I'm going to go below there now. So you got to go over the table. All right. Now, why are we doing all of this? Because later on, when it comes to some part of your engineering discipline, you are going to use these terminologies because it would just simplify the processes, the calculations that you are making. And then it would make sense. So these terminologies were really created because of our application. So we're really forced math into creating terminologies that would make more sense for our applications. That's where the dominance of engineering is coming from. So somebody said cotangent of theta, which is an inverse of tangent of theta. So if tangent is y over x, what is cotangent? Who said that? See? When you stop eating, then you can answer. All right. So let's do some examples. Now let's assume that theta, now let's just imagine that arm. The arm now are at different positions. At 0 degrees, 90 degrees, minus 90, and of course plus and minus 180. Right? Now we want to find the values of x and y and cosine and sine of theta. Okay, so the first one is theta is equal to 0, or 0 degrees or 0 radian. Right? The arm is right here. Right here. Just by observation, what is the x and y of the tip of that arm? X is equal to, and y is equal to 0. All right? And what is the theta? Okay. So what is the cosine of theta? Cosine of 0 is?
No,
1. Right. Cosine of 0. Cosine of 0 is 1. And the sine of 0. So just by observation, I can give you the answer, or by inspection, right? And x equal to L cos of 0 degrees, which is equal to L. By observation. So if I'm looking at this and say, okay, by observation, L cosine of 0 degrees is equal to L, does that mean then cosine of 0 is 1? Yeah. So cosine of 0 degree is 1. I can also go over here because the hypotenuse is lying on the x-axis, so these two are equal. These two are equal. And if cosine is x over L, is L over L, and therefore cosine of 0 degree is 1. You look lost though.
Me?
You're shaking your head, but then you look puzzled.
Oh, no, I get it. I
Oh,
get it.
okay, you're just stunned. Yeah. Yeah? Okay. All right. What's that? I'm sorry? Are we assuming the right girl? You tell me. Are we assuming? No.
The wrong
Are-
word,
are-
as in I'm the puzzled one, not her.
So he's asking, are we assuming L equal to 1?
No.
Answer it.
It's like cosine is 1, so wouldn't that be like, hold on.
This is,
Cosine
oh,
is
maybe he's confused because this is not 1. This is supposed to be L.
No, that's L. Because
That's L.
Cosine of 0 is 1, so L times 1 is L.
Yeah.
Yeah. Yeah.
You see, because L cosine of 0 is equal to L. So what should cosine of 0 be in order for that? Why? Yeah. That's right. Do you get it?
It's like, duh.
Come over here. Come over here. Let's teach it to the class. Come on. Come on. Tell me. Come over here. Yeah, you're gonna be over there now. Go on.
For x equal to L, right? We have time like L times cosine 0. So that means cosine 0 has to be 1 because L times 1.
Should. Yeah. So in other words, this is how we do it. So let's say 4 times x should be equal to 4. So what should x be?
1.
Right. So when I say L times x is equal to L, what should x be?
1.
You get that? So, yes?
Yeah, I got it.
So if I now say L cos of 0 is L, which means cos of 0, exactly, 1. Now we can go home. What's that?
Why did you use so complicated language?
Why?
You could have put an X there. No, you couldn't.
No, but like
He's asking a legitimate question. Yes, go on.
but like the cosine of 0, isn't that something that you have to like, how do you say it? Like it's not like an explanation, but like it's something you have to like know, just like.
Well, yes.
sine-
I mean, you do know cosine of 0 is equal to 1. But I'm also showing it by inspection. It's also proven. So it's not like, we've made it up. Cosine of 0, it is equal to 1. And we have not made it up. But what I'm saying here is that even if you inspect it, you will see that you're right. In fact, cosine of 0 cannot be anything other than 1. Right? So what is sine of 0 here?
0.
Yeah, okay. Sine of 0, you already know that it is 0, right? What's that? No, sine of 0 is 0. Right. Come on, you're doubting yourself?
Yeah.
I'm going to put you in the corner in a second. Wait a minute. So, no, don't talk. Don't talk. Listen. So here's another thing. So we say that what is y in this case by inspection? By inspection, what is y? Y is equal to sine. First of all, y is equal to L sine of theta, right? This is what you do, right? Or sine of 0 degrees. But it's also, by inspection, what is y? 0. There is no y coordinates here. Is there a y coordinates here? No. So this is equal to 0, right? So you know that L is not 0. So what should be 0? Sine of 0 should be 0. Right? Again, by inspection. Now, if I want to also show it graphically, y is equal to 0. Right? And from here, we are saying that sine of theta is y over L. Now, y is 0 over L. Therefore, sine of 0 degree is equal to 0. two ways that we are showing it by inspection and we are showing it by math. Both of them. All right, so let's go to the other one. Theta now is 90 degree. All right, 90 degree or pi over 2 radian. Why is it pi over 2?
Because no, that's not.
Because it's halfway to what
Yeah.
and
She said-
180 is half.
There you go. Right? She's smart, huh? Yeah. Yeah. All right. Yeah, wait until 2 weeks. I'll tell you. It's easy to say that now. So now, again, there we are. Now we want to do by inspection. The whole objective is we want to find the x and y. So, by inspection, what is the x of the tip of this bar? 0. And the y?
1.
Y is 1? L. Y is L. The length is L. Okay? So by inspection, y is equal to L, and x is equal to 0. Right? Do we agree?
Yep.
So, x is equal to L cos of 90 degrees, which is equal to 0. Why? Yes, you tell me. Yes, you were about to raise your hand. I saw it.
X equal 0 because,
Look at this. Where is x? X is right here.
right.
So x is 0.
X equals 0, so it has no choice because 0 times any number is 0.
Right. So can L be 0?
Yes. No.
No. L cannot be 0. So what should be 0?
Cos.
Cosine of 90 is 0, right? Just by inspection. The cosine of 90 is 0. So what is y? L, right? So y is equal to L sine of 90 degrees. Huh? There you are. You said it. That's it. Bingo. Say it again.
Sine of 90 is equal to 1.
You're gonna remember the sign.
It's all about the unit circle.
There you are. But no, but even by inspection, because you're saying y is equal to L sine of 90 degrees is equal to L. So L and L on both sides. You can cross them out. Therefore, sine of 90 degrees is 1. There you are. Easy. Yes? Good. Go to the other side. Minus 90 degrees. Or minus pi over. So why is it? Yes.
Why aren't we measuring the full 360 degrees? How come we stop at 1?
I want to make life difficult for you. But now,
Find like the on at every point of the circle.
why?
Weren't we supposed to find like at every point of the circle?
Yeah.
The arm, so that's what
Yeah, but I want to also show you that I picked up the simplest form so you can compare it by inspection. If I put it in the middle, then it would be very difficult to inspect, right? So if I bring it down, I could either say 270 degrees, or I can simply say minus 90 degrees. But what we said before, if you remember, I said you measure theta from 0 to plus 180 degrees and 0 to minus 180 degrees. That means I did not want you to go over 180, right? Otherwise, we could have gone to a whole 3 quadrants. So by inspection now, what is y?
Y is a negative L.
Negative L. Negative 1. Who said negative 1? Why negative 1? Yes.
Because
You said L. What are you trying to defend her?
I'm trying.
You said the
I
right.
know why. That's why.
Oh, you know why she said the wrong thing?
No. Like,
She said 1.
Never mind. I just
She
know
said-
it
she
too.
said-
Like I said, that's how I was answering. But okay, I go. Sorry.
Negative 1 is wrong. Yes. You want to say something?
Negative 1 is wrong.
Yeah.
How is it wrong?
Where did you get 1 from?
One from like sine. Like okay, sine of 90 is 1. So
I did not say sine. I said y. Y is negative L.
Yeah, I already said that, but
No, but she said 1. You're supporting her.
I wasn't supporting her. I was looking at the end of the.
Listen, I'm video there. We're gonna put it on the web. So no denial. No denial. Right, yes, sir. What's that? Yeah, you're on the tape. Right. Yes.
Well, you were saying that you were asking for the value of y.
Exactly.
She was given the value of the
Sine, right. Nobody asked for the value of sine.
I said negative L, but then she was jumping ahead, so I jumped ahead too.
No, you didn't say. I see. I have the tape. See, I should have told you we're recording you, so and it's gonna be all over the web.
Oh my god.
All right. So anyway, going back here. So y is a y coordinates on the tip of the robot, right? The tip of the robot is about L distance away from the origin, therefore is negative L, right? What is x? 0, right? So knowing these two again by inspection, x equal to 0, y is equal to negative L. X is L cos of minus 90 degree, which is equal to 0. What does that tell us? You tell me. From this here, what can you find? No, I'm asking that gentleman back there. What's your name? Josh. Josh, what is cosine of minus 90 degree? 0, right. Why? Because L cannot be 0. L is a length. Therefore, cosine of minus 90 degree must be 0. Right? That's why if somebody says, what is cosine of minus 90 degree? You say 0, which is same as cosine of 90 degrees. Whether you are negative theta or positive theta, as long as that's 90 degree, you are still the same value. So we have x. What about y? So, sine of minus 90 degree. What is the sine of minus 90 degree?
Negative 1.
There you are. Negative 1. Now, who said negative 1 before? So she was 4 steps ahead of us and she didn't know it. Right? So sine of minus 90 degree is negative 1. Why is that? Why is sine of minus 90 degree negative 1?
Tell me just the inverse of. Okay, wait, no. Yeah, it's inverse from when theta was positive. Well, not.
Look at this equation. Yes.
you divide by L, and then you take out the negative sign from the sine 90 and put it to the other side, and the negative to the positive.
Right? We are saying that L sine of minus 90 degrees is equal to minus L. If you cross L out, what do you have on this side? Minus 1. Therefore, sine of minus 90 degree is equal to negative 1. Can you do theta is equal to 180? Come on, tell me. So if theta is 180, in other words, the bar is over here. What is x of that? X of the tip?
1. No, 0. 0.
Negative? Where do you get the 1 from?
It's 0.
Negative L.
Huh?
This bar comes over here. The length hasn't changed. Right?
That's why you keep getting -1.
Yeah. Minus L. Minus L. So that if theta is 180, your x is going to be minus L. Right?
Wait, I don't see how it's gonna be minus.
She doesn't see it.
I don't see it
Because you're sitting back there.
no, I can see it.
Oh. If I were sitting over there, I would not see it.
No, I can see, but I'm saying I don't understand like how.
She doesn't understand. You need. Come on, tell her. But I know, but you want to answer every question. Let the man speak.
Sorry, it's like,
All right.
I don't know.
Well, you're asking for that. It's again, you're asking for the actual value of x, which would be negative
X coordinates, right?
coordinates, whereas you're thinking about the unit circle and the value of the unit circle, which would be 1 or -1. That's why it's good.
This comes over here. The length hasn't changed. The length is a rigid bar, right? So the bar is, it's about L distance away from the origin. So therefore, the x coordinate is minus L. What is the y coordinates of the tip? That's 0. So now you have x as equal to negative L and y as equal to 0, right? So what is the cosine of 180 degrees? -1, right. Why is it -1?
Because that's the negative L, so
Because
-1.
x is equal to L cosine of 180 degrees, which is equal to negative L. So L cosine of minus 180 degrees is equal to negative L. If you get rid of the L's on both sides, it says cosine of 180 degree is -1. Right? So what is the sign? Of 0. Why? Because y times sine of minus 180 degrees is equal to 0. Since L cannot be 0, sine of minus 180 degree has to be 0. Yes, have question?
So am I correct in saying that the unit circle is only relative to degrees?
Absolutely, yeah. You put you're going to back to trig circle. I'm not giving you that. The reason that I put L is because of that confusion. I'm showing you that the trig that you're using can allow you to find the tip of your robot of a length of L. Now, if that L is equal to 1, then it becomes your circle of sines. Yes?
But you can use a unit circle to figure out the angle.
Absolutely you can. Yeah, but those are for people who are really expert in that unit circle. Right? So now we have 45 minus 145, 135, and 100 and minus 135. Right. So 45 degrees. So you see who can jump in there and immediately tell me by inspection what is x and y. Yes.
Oh, wait. You want the,
I want to know x and y.
Oh, I think I know X and Y. I think I know.
You do?
Yeah.
Yeah, you should. Right angle triangle. Yes.
I would say X is 1 and Y is 1.
No, she's way out.
Really?
Absolutely. Yes. Yes. X is 0? How can x be 0? I mean, look at this.
Oh, no, y is 0.
Why y is 0? Y is not 0.
Why is it? Oh.
All right. Yes.
all right, so x is going to be the sine of, no, the cosine of 45 degrees. Y would be the sine of 45 degrees. But that would be equal to
1 over 2.
2 over 2.
1 over
So look at that triangle.
2 radical 2.
So
Yeah.
so this is what we have, right? X is equal to L cos of 45 degrees.
I knew that.
Now, wait a minute. What, I could put pi over 4, right? So L cos of 45 degrees. Yes, you keep forgetting about L. Cosine of 45 degree is equal to 1 over square root of 2. Now you know that, right?
Yeah. Yeah.
Right. So it's L over square root of 2.
Wait, I don't get why it's wrong then, because isn't it like x is 1, y is 1, and then L will be like square root of 2?
Yeah, but
That's what I
L,
was saying.
I know, but L is not the square root of 2. L is L. So you're going to find x and y in terms of L.
Oh, okay, I get it. Sorry.
Okay? Yeah, I mean, if those were 1, then you would find L. So do you understand this? Yes.
Well, wouldn't that be, wouldn't you have to write L square root of 2 over 2?
Yeah. Yeah. I mean, this is what you're saying is, so what he's saying is, part of being an engineer is that we're very lazy. Because if I have, so what he's saying is L over square root of 2, right? So if I multiplied square root of 2 by 2, denominator and so what do I have? I have L square root of 2 over 2. I'm already tired, all of these calculations. Well, which one is easier? L over square root of 2.
Yeah.
Right? It's the same thing. That you want it this way, you can have it this way. Okay?
I always thought that was undefined. That's what we want.
What do we know? The square root of 2 is 1.7, so it can be defined too. So anyway, so let's look at y.
It's the same thing.
Same thing, right? So we found x and y. Could we have done this by inspection?
No, you have to know like the 40, you know what I mean? Yeah, you have to know the.
So what I have here, I have a triangle. Okay? My triangle is L, and this is x, and this is y. Right? In this triangle, would I be able to find x just by observing?
No, because
In a 45 degree, if this is 45 degree, what is this one?
45.
So if it's 45 and 45, what kind of triangle do I have? Huh? It is a right triangle. What else? Isosceles. Right. So this also, I can say this is also x. So I can say x squared plus x squared is equal to L squared, right? Or 2x squared equal to square root of 2, right? Or, I'm sorry, what am I doing here? L squared, right? So I can say 2x squared is equal to L squared, or x squared is L squared over 2. Therefore, x is equal to L over square root of 2. Same answer, right? But I use a different theory. What theory did I use? I use the concept of isosceles triangle, but within a... Exactly. There you are.
If it was, instead of like being like, if it was like pi over 6, would that be like 60, 30, 90 triangle? Would you use that?
Well, that would be a different angle.
Yeah.
Yeah, of course, that's a different angle, but this is for 45. That would be for 30 degrees,
Okay.
right? That would be 30, and then we use it at half and the square root of 3 over 2. So x and y, the tip is equal to L over square root of 2, both for x and y, or he prefers it at L square root of 2 over 2. Okay? Extra effort. Either one is fine. So, minus 45. So now I have 45, I have minus 45. Can somebody tell me immediately what is x and y of that? Huh? Right. Both of them are, or one of them are? Which one? Y, exactly. So the y is a negative of that.
Oh, because I know what.
So by inspection, if I knew that, I can find the other one, which means that x is equal to L cosine of minus 45 degree, which is the same. So cosine of minus 45 is the same as cosine of 45, based on the comparison between the two. Right? Yes?
Is that because in quadrant 4, like every I think the cosine in quadrant 4 is always positive, right?
Yes.
So is that right? Okay.
Yes. You're jumping ahead.
Shit, sorry.
Yeah,
Oh,
that's all right.
Sorry for the word.
That's all right. See, you're forgetting.
Sorry, I know. I'm so
See,
sorry.
now it's going to be all over the web.
I know. Can you erase that part?
Absolutely not. I'm going to magnify it. So sine of minus 45 degrees, right? Why is sine negative? Yes.
Because it's flipped. It could have been on the other side of the
What is sine? Sine is equal to y over L, right? Y over L. L is always positive. L is the length, right? So it's the sine of y that determines the sine, right? Sine is always y over L. So in this quadrant, y is always negative. In this quadrant, is y negative?
Yes.
Yes. What about x?
Yes.
Yes. So in this quadrant, both sine and cosines are negative. So we're going to get to that in a second. So these quadrants that we have, they also determine the sign of your sines, your angles. Okay? So far? So x and y for minus 45 degree, if you compare them, they are identical in value and they are opposite in sign in the y. So far so good? So 135 degrees. So if at the 135 degrees, I want to find x and y. Yes. Now don't answer that. But before, the x, is x positive or negative?
No, negative.
Negative. And y?
It's because it's
Positive, right. So sine is equal to
Y over L.
y over L. So would sine be positive or negative? Negative?
it's positive.
Positive.
Yeah.
Because y is positive. Cosine?
Will be negative.
Tangent?
Will be negative.
He's puzzled. Why tangent is negative? Go on, try. What is tangent? What is tan of theta here? What is the formula for tan of theta? No, don't say that. In terms of that triangle. What is tan of theta? Y over x. Right? Tan of that angle is y over x. Right? Y is positive. X is negative. Therefore, tan is negative. Tan is also sine over cosine. And we said sine is positive, cosine is negative. Therefore, if it's one positive and negative, then it becomes negative. Right? By observation, by knowing the formula, I can find out what the value is before even doing the calculations. And this is very important. Because in engineering, when you are dealing with problems, you also have to use your common sense. Okay? So before even you start your calculation, you can basically have a feeling what the answer would be. And this is something essential that you must have in engineering. You remember, we use a lot of software in engineering these days. And always people feel, well, that's the information that I provided, and the answer is wrong. But we also have to have a sense what that answer should be before we put all those numbers in and get an answer. The same thing goes as simple as this. So if I'm looking at finding the sines and cosines, in fact, in this case, I want to know the tip of my robot, one-arm robot, right? Yes, you have a question? I thought maybe you have a headache, You know questions? You're okay? Right. You have a question too? Okay, good. So x and y. So what should I do? What should I do in order to find x and y? X is equal to?
L cos 135 degrees
Uh-huh.
equals, what it equals?
Cosine of 135 is minus 1 over the square root of 2. Yes.
Just helps me to think about it like as a 45-degree angle.
From this side. Yeah, but the reason I'm showing you this way is that you also have to think of it as a mechanical system. If I wanted to just do geometry, I would just do minus 45. But you have to start thinking about this as a mechanical system. This is a dynamic system. This is something that is moving. It's kinematic. It's moving. Therefore, you cannot just change it to your liking because geometrically it makes more sense. In fact, you are measuring it from this here at 135 because your motor is turning all the time.
Okay,
Yes.
So because we really
Right.
counterclockwise.
Yes. Exactly. Counterclockwise is always positive. And we measured it from 0 to 180 degrees. If this had come over here with 45 degrees, instead of saying that I want to measure it at 225 degrees, which is 180 plus 45, what do? We say minus 135 because we measure it from 0 to minus 180. So in this case, L cos of minus 135, which is L times minus 1 over square root of 2, which is L over minus L over square root of 2. Or minus the square root of 2 times L over 2. And what is y? What is y?
Is the same? It's like 1 over square root of 2.
1 over square root of 2,
Like
yes.
L times 1 over.
L times 1 over square root of 2.
Which is L over square root of 2.
Exactly. So she did it by observation. Because x and y are equal.
Yeah.
And y has to be positive. Which is good. No one's going to blame you for it. This is your beginning to form your opinion by observing. Okay? Agree? Do we need to do this? No. Just by observing, you can just guess what the answers would be. Right? All right. So, I want to summarize it. I'm going to let you go after this. I finished this part because of... do you have any classes after this?
Yeah.
Oh, you're going to stay?
Oh, no, one more class.
Yeah, I have recitation now.
You want to stay? Okay. Because at 4:30... Huh? Has he canceled? I don't know. He hasn't canceled. But, well, all right. So, we want to do the sines, cosines, and all other functions depending on the quadrants of the reference angle. So you have a reference angle and the quadrants. Now we have 4 quadrants going back to that unit circle. Quadrant 1. in quadrant 1, sines and cosines, they're all positive. Right? Do you agree? Why are they all positive? Because x and y, they're both positive. So whenever your reference angle falls within that quadrant, sines and cosines are positive. Quadrant number 2, sines and cosines.
They're all negative except for sine is positive. Sine is positive.
Sine is positive,
Cosine
cosine is negative. Agree? All right. Quadrant number 3.
Tangent is positive.
But sine and cosine,
Are negative.
right? Both of them negative. And quadrant number 4,
Cosine is positive. But sine is negative.
there you go. So these are the terminology that you have to remember only by knowing x and y. X and y. You know, because sine is y over L, cosine is x over L. As long as we remember that, then you know that sine. But then, you know, this is based on measurement from the positive x-axis. So you don't do that minus 145 anymore. You will do it 135. All right, so some reference angles for you to remember. It's very hard to see, but these are the reference angles and the sines and cosines and tangents. From 0 to 90 degrees. 0, 30, 45, 60, and 90 degrees. I will show you some tricks later on in some other sessions on how to come to those numbers. But these are the sines and cosines of these angles that you need to remember that would help you in your analysis. These are the things that you must already know anyway. The sine of 90 degrees is 1. The sine of 45 degrees is the square root of 2 over 2 or 1 over the square root of 2. Sine of 30 degrees is half. Sine of 60 degrees is the square root of 3 over 2. And if you look at it, the cosine is the reverse of that. You see that? Everything is in reverse. Okay? So these reference angles are important because sometimes when you want to do some quick measurements, let's say that if you have a cosine of 32 degrees or 35 degrees, 35 degrees falls between 30 and 45. You get a measure of what that value should be. So if I find a cosine of 35 degrees as to be a little bit more than half and less than square root of 2 over 2, which is about 0.7, so it has to be between 0.5 and 0.7. So if I calculate it at 0.8, that means I'm out. If I'm calculating it at 0.6, that means somewhere in between. So it has to be some form of a measurement that you can very quickly calculate. Yes?
If you had the sine of 35,
Right.
what would be the radian of that? Like
Pi over?
6?
No, pi over 6 is 30. You got to find a number that makes it 35. So, well, some ratio of pi, whatever that 35 is. Now, if you want to really find it, all you have to do is divide 35 by 180, right, and multiply it by 5. 35 by 180 times pi. Okay? Any questions so far? So, if I have 120 degrees, we don't have, those are not reference angles anymore. So 120 degrees. So L cos of 120 degrees, which is equal to minus L cos of 60 degrees. Do you see that, what I just did? over there? What did I just do? Something I told you not to, right? But in order to do this very quickly, instead of 120, I put 60 degrees, because cosine of 120 and cosine of 60 based on observation is the same. I already know what a cosine of 60 degrees is, right? I don't know what the cosine of 120 degrees is, right? But by observing and remembering, I simply put for the value of cosine of 60 degrees, which is half, and find the value of x.
So you can take half of a number, and then like.
What did I do over there? Yes.
You use the chart as like a guide. So you see it's 160. You said, well, I don't know what 160 is, but I know what 60 is, and then you just build in the one.
Exactly, because cosine of 120 and cosine of 60 is the same. Look at this. Their cosine is the same,
Okay.
right? So this is what we do. That's why you remember those reference angles. Then this way will assist you to get those numbers very quickly. Yes?
When you do that, you gotta switch to L for negative.
Yes. By observation, right? Because all we have done over there really is, if I have cosine of 120 degrees, is simply cosine of 180 degrees minus 60 degrees. That's what I'm doing. But a cosine of 120 degrees is simply minus cosine of 60 degrees. But by observing, I know that L falls on the negative side. I don't have to do that anymore, because I know that this has got to be negative, right? It has to be negative, because cosine of 60 degrees is positive. Cosine of 60 degrees is positive, but cosine of 120 degrees is negative. Okay? So although you're using those reference angles, you have to be cognizant of which quadrants you're in. You are in quadrant number 2, therefore your cosine must be negative. Now, what about the sine? The sine is the same, positive. In the second quadrant, sine is positive, cosine is negative. Therefore, sine of 120 is the same as sine of 60 degrees. Right? To just basically bring to your attention what you must have learned somewhere else is sine of A plus B, sine of A cos of B plus cos of A sin of B. You know, these are the terminologies that you had in your trig long time ago. That's where you refer to this cosine of 180 minus 60 degrees. Therefore, you can use this formula. So which one is easier? That or this?
That.
There you are. Okay? I bet nobody has ever taught you that. There you are. But you see how easy as compared the two.
Do you need to know them both? Or?
You know, you choose. Now, in this case, we have 120 degrees. But what if you had 118 degrees? You know?
Take half, which would be 90.
You have to. I mean, in that case, you need a cat. Yeah. So we're only talking about angles that can easily be broken up into those reference angles. 0, 30, 45, 60, and 90. So if I have a 15 degree, right? 15 degree comes from 45 and 30. Okay, 45 degree and 30 degrees. Therefore, you cannot use that anymore, but you can use these and then put those values in. Okay? But if I have 72 degrees, then I cannot use those reference angles because those reference angles do not exist. So it is important to know both of them, but then it would be your decision to choose the one that is easier to use. Do you understand?
Yeah, I get it.
Yeah. Good. Which gives you the same answer. So, now we have an inverse problem. The inverse problem is now we give you x and y. Now I want to find out what L and theta is. Now that should be a piece of cake for you now, right? So what we know is that in many of the mechanical systems, you also have a position control. The position control gives you the xy coordinates all the time. When you look, in electrical engineering, when you're looking at the pixels, you want to locate the location relative to an origin, but you only have the xy coordinates. In that case, you need to have L and theta, right? Before we were giving you L and theta, and we were asking for x and y. Now we're giving x and y, and we want to know L and theta. How do you find it? How do you find L if you have x and y?
Oh, you write your theorem?
Yeah, that's one. And then how do you find theta?
You do the inverse, like, for example.
You have sine and cosine. You have
Yeah.
tans. You can get arctan, right? So this is what we're going to learn. How do we find L and theta? So you know that x is equal to L cos of theta, y is equal to L sine of theta, and using the formula, you have x squared plus y squared is equal to L squared cosine of the 2. So therefore, if you want to find out what L is, all you have to do is using, there you are. In this case, L would be equal to square root of x squared plus y squared. And if I want to find out theta, theta is arc tan of y over x. Tan minus 1 is called arctan. How many of you have seen that? And the rest of you haven't seen it. All right. It's called arctangent. How many of you have calculators? Calculator, yeah. Scientific calculator. Do you have one? Is there a tan minus 1 there? Is there something else in there? Do you have tan 2? A tan 2? Do you have A tan on your calculator? A tan 2 on your calculator? Yes.
Isn't that the formula you would use for like polar coordinates and rectangle coordinates?
Polar coordinates and rectangle. This is rectangular coordinates. Polar coordinates is L and theta. Right. All right, so we're going to refer to your calculators. If you have one, I'm sure most of you have smartphones and you can download calculators, scientific calculators. But you have to be careful because some calculators only have A tan, which is arctangent, and more advanced have A tan 2. The difference between A tan and A tan 2 is A tan 2 takes into account the quadrants that you're measuring the angle. The problem with A tan is that it only measured it between 0 and 180 degrees. So it will give you the wrong answer. This is, let me see, what does it say? Some message about temple. School's open tomorrow. That's interesting. Temple domestic campuses will open and classes will begin at noon tomorrow.
At noon,
Yeah,
everybody, I'm gonna.
yeah, all right.
Oh, I was like, school is open tomorrow at noon? I don't get it.
Yeah, so in the morning classes are canceled.
The morning, oh my God, I have no
Yeah.
classes tomorrow.
That's a shame.
Never mind, I got recitation.
All right, so again, we want to find L and theta for the following points, x and 1. So x and y at 1 and 0. So you loved 1 so much. There you are. Yes.
Oh, I thought you were.
No, I mean here, if I want to find what L is, what is L? And theta? 0, right. So by observation, we find L as 1 and theta is 0. By formula, L is equal to square root of x squared plus y squared. And theta is arctan of 0 over 1 or arctan of 0, which is 0. Right? Both inspection and formula. The vertical location, 1 and 0. Now we want to find the L. What is L? Inspection. L is equal to 1 and theta 90. This is inspection, right? By inspection and then by formula. Any questions on this? We're basically doing the same thing, but much more quicker. Don't worry about it. These are all going to be on your blackboard. So this one, x and y, 0 and minus 1. By inspection, L is equal to negative 1. Can L be negative 1? L is 1, is length. Okay? And theta? Negative 90. Negative 90 or 270, which one? Negative 90, because you remember we said measure it from 0 to 180 and 0 to minus 180. Okay? So we consider these two cases. All right? We want to find out theta and we want to find out L. Two cases. What is the value of L? Yes. 1 over 2 squared, is that correct? No. What is it? 1 over? What is L? Yes. Right. So 1 over the square root of 2 is 1 over 2 plus 1 over 2. What do you have? 1 half plus 1 half. What do you have? 1. Yeah. L is equal to 1. Is L equal to 1 in both cases? Right. So then I want to find out theta. So if I want to find out theta, in this case, theta is equal to arctan of 1 over the square root of 2 over 1 over the square root of 2. So what do I have? Arctan of 1. Theta is arctan of 1. Right? Arctan of 1. So what is theta? Do you have a calculator? Do you have a calculator? Find an arctan of 1.
Oh, an arctan of 1.
Arctan of 1. 45. 45 degrees, right? And in this case, we have arctan of 1 again. What is theta? (45). Is 45 correct? No. How come? Huh?
It's not, I thought it was, if it's a isosceles triangle, it's a 40, it's,
Yeah, but I'm using the formula. I'm using theta as arctan of 1. Exactly the same. Why is this not 45? Aren't they the same? Look.
It's not on mine. I was gonna say 130.
It is 135. Well, why is it not giving you 135?
Because
Coordinates are right, like it's saying it's in the first quadrant, which it should be a positive x and a positive y, but the line is, you could clearly see it's in the third quadrant, that means it's both negative.
That's why you have to understand the quadrants. That's why you have to understand the quadrants. X and Y is important because it will tell you which quadrant it is in. So even though the mathematics is telling you 45 degrees, your calculator is giving you 45 degrees, the answer is incorrect. It is not 45 because X and Y is dominating that angle. Because X and Y is pushing you towards the third quadrant, therefore you already know that it has to be more than minus 90 degrees. Right? Therefore, this answer, which will give you 45 degrees, is absolutely wrong. That's why some of your calculators have something called A tan 2. Now, where A tan 2 take into